Hey guys, welcome to my second video on the course, Mechanical Control Systems. In this video, I will talk about inertial elements used in mechanical systems. There are three types of inertial elements. Number 1, the one with translational kinetic energy. Number 2, with rotational kinetic energy only. Number 3, with translational plus rotational kinetic energy. Let's go to number 1. In this case it is a mass moving with a linear velocity v. The kinetic energy in this case is half times m times x dot squared. Number 2, if there a disk hinged about center point, O and its center of mass is coinciding with the hinge point. Then the velocity of center of mass is 0, but it will have rotational kinetic energy due to rotation of the disk. So, if the disk is rotating with an angular velocity omega or theta dot and j is the moment of inertia of the disk, the rotational kinetic energy is given by half times j times theta dot squared. Number 3, if there a compound pendulum, hinged about point O and, the center of mass is at a distance 2r from the center. When there is an angular velocity theta dot, of the compound pendulum, we can see that the center of mass, will now have a velocity which given by the formula theta dot times 2r. Therefore, the kinetic energy of the system is the sum of translational plus rotational kinetic energy. In this case, translational kinetic energy is given by half times m times vg squared. And, rotational kinetic energy is given by half times j times theta dot squared. So the total kinetic energy equation can be written in terms of either one of the independent variable. In this system there are two independent variable, x, that is the displacement of the center of mass, and theta, that is the angular displacement of the compound pendulum. In terms of theta we can write vg or x dot as theta dot times 2r and substitute in translational kinetic energy term, and we obtain the total kinetic energy in terms of theta. In terms of x we can write theta dot as x dot divided by 2r and substitute in rotational kinetic energy term, and we obtain the total kinetic energy in terms of x. So from this video we have learned how to write kinetic energy of different types of inertial elements. In the next video, I will explain about gravitational potential energy and its linearization.